Hello, and welcome to our presentation on bridging the gap between legacy SaaS and SaaS Viya at the Centers for Medicare and Medicaid Services. My name is Rick Andrews, and I am a programmer analyst in the Office of the Actuary at CMS. Helping with this paper this year is Kevin Boone from the SaaS Institute. Kevin is a SaaS user coach at CMS, and he teaches people how to use the SaaS software and coaches us on various new initiatives that we have at CMS, and will be helping us to learn this new evolution of SaaS Viya in the future. Also helping us with the paper this year is Manuel Figallo, also from the SaaS Institute. Manuel is a principal systems engineer and solutions manager at SaaS, and he has been using SaaS for big data analytics for many years. He started his career in artificial intelligence research and recently has been working with the government business unit and has been working with Medicare and CMS for many years as well. Today we'll talk a little bit about bridging the gap with a little history of SaaS at CMS and this evolution that we're currently going through. So along with a brief history, what do we mean by bridging the gap? And what we really mean is this migration or integration with new tools. I will talk a little bit about our current state at CMS, give you an example of how we process data using our legacy mainframe, convert the process to a client server application using Enterprise Guide, and also in our current state, how we can use a tool called SaaS Studio on the web. Now, most users at CMS would use mostly SaaS coding to do their processing, but we also have a number of visual tools within SaaS that can generate code for us. So I will provide one use case where we utilize explicit pass-through and also using the various query builders. In addition, Manuel is going to speak with us about our future state at CMS and how we're going to migrate to the cloud. Also an overview of SaaS Viya and another use case utilizing the SaaS Viya platform and Python integration within a web browser. Finally, we'll give you a roadmap and our conclusions about how we at CMS are going to best bridge the gap between our current state and our future state. Real quickly, a history of SaaS and CMS. As many of us know, Medicare was signed into law in 1965 and was managed by the Social Security Administration up until 1977 and ultimately became CMS. Whereas SaaS originated, the programming for SaaS really originated back in 1966 and was funded initially by government agencies, various projects from the Department of Agriculture and the National Institutes of Health. So one reason I just wanted to present that is the government, especially the Department of Health and Human Services, which NIH is a part of, as well as CMS, HHS really was instrumental in helping to fund the beginnings of the SaaS system, which now, the SaaS Institute was incorporated in 1977. So Health and Human Services really was at the forefront of helping develop the SaaS software. And the reason I mention that is, this presentation is meant for training purposes only, and The opinions of the speakers are their own, and we're not here to market or advertise SaaS from a CMS standpoint, because SaaS has always been at CMS. It was at CMS even before we became CMS. So we're really here to talk about the evolution of SaaS at CMS. Bridging the gap to continue, at CMS we have used SaaS on a mainframe for many, many years. And the nice thing about using SaaS is that we can integrate with various data sources, data warehouses. Currently at CMS, we use databases like Teradata, Oracle, DB2, and we can integrate very easily with the SaaS software. Now, some years ago, maybe a dozen years ago or so, we did a migration to a client server and a web-based application called the Enterprise Business Intelligence Server. So we migrated a lot of our processes, most of our processes, from the mainframe to this client server environment. And what CMS would like to do in this next evolution is move away from the client server into a cloud-based environment, utilizing a cloud service provider. One reason this is a real good idea for any agency or entity is that we can rent space from a service provider like Amazon Web Services or Google, Microsoft, Azure. There are many different companies out there that we could rent space from, so that way we do not have to purchase hardware and software ourselves. We can simply rent from a company. And once we move to a cloud-based environment, we can utilize tools like SaaS Viya, which gives us many new options for processing data. Things like utilizing Python is one aspect. And in addition, we still have that integration with data warehouses. Along with all the other tools that we just mentioned, we could use databases like Snowflake and Hadoop and Postgres. So any database can be accessed using the cloud. So very quickly, just wanted to give you an image of where we are today in our current state. This is a quick snapshot of a SaaS program on our mainframe that accesses one of the databases. In this case, it's a Teradata database. And this is how we would have typically used SaaS in the past for many, many years. But about a dozen years ago, we migrated to this client server environment, typically utilizing Enterprise Guide on this client server. Now, in this example, what we've done is simply copied and pasted the program into Enterprise Guide, and with a couple of very small changes to the live name statement and the connect statement to the database, the code is exactly the same. Also in our current environment, we are utilizing SaaS Studio on a web browser. The nice thing about SaaS Studio is that you do not have to log in to a client server environment. You can simply launch a web browser, and the program is exactly the same as in the client server. It will produce the exact same results. Now, a lot of us, are not interested in learning SaaS programming. One nice feature about SaaS in our client server environment is that you can utilize the visual query tools. In this example, we're looking at an enterprise guide query builder on our client server. And this is a point and click environment that will produce the exact same results as in the previous programs that we just mentioned. In addition to the client server, the web-based tool in SAS Studio is almost exactly the same as Enterprise Guide. It looks and feels almost exactly the same, and it will produce the same results. So that is a view of our current state at CMS. And what I would like to do now is turn it over to Manuel Figallo to talk a little about our future state. Manuel, could you speak a little to us about the future state of SAS Viya at CMS?
Rick, thank you so much. I'd be happy to. And thank you for that overview of the current state at CMS. The future state consists of a web browser, which allows end users to access SAS Viya applications from a desktop computer. Viya is SAS's next generation high performance in-memory analytics platform designed to run in the cloud. SAS Viya includes applications such as SAS Studio, as you see on the screen for programming and flows, SAS Visual Analytics for dashboards, and Python notebooks to run data or machine learning pipelines that integrate with SAS Viya. So if you're comfortable with the web browser, then you'll be comfortable with a lot of the capabilities in SAS Viya. To summarize, SAS Studio provides a programming environment for developing and submitting SAS programs to the cloud server. SAS Visual Analytics provides reporting, dashboarding, and statistics functionality, or more specifically, analytical data preparation, variable transformations, exploratory analysis, and descriptive statistics. These are just some example capabilities. A web browser also enables you to integrate with Python with SAS Viya, as I described, using the SWAT package. SWAT stands for SAS Scripting Wrapper for Analytics Transfer. It's a mouthful, but that basically enables open source software such as Python and R to run data analysis and build dashboards on the SAS Viya server. On that note, one best practice is to augment Python capabilities with Viya applications in the cloud for discovery and for deployment in a scalable and secure fashion. Here, we are showing a Python pipeline integrated with SAS Viya to produce role-based and secure dashboards and reports for widespread distribution within CMS. We have used this approach at SAS to better understand hospital and nursing home care during the COVID-19 pandemic among Medicare beneficiaries. In SAS Viya, a web browser interacts with SAS Viya using microservices. This future state slide describes the three main components of SAS Viya. I've already mentioned microservices. SAS Viya also includes Cloud Analytic Services, or CAS, which provides the runtime environment in which data management and analytics takes place. Cloud Analytic Services is a server that is suitable for both on-premises and cloud deployments. As depicted by the three blue squares, the in-memory analytic features of CAS can be achieved by distributing the CAS server across multiple nodes to enable MPP, or massively parallel processing. One advantage or benefit of MPP is that because data is in memory, results can be produced much more quickly. The last box, denoted by red, is the SPREE engine, or the SAS Programming Runtime Environment. It is also referred to as a compute server in SAS Viya, and it is the equivalent of most everything CMS has today. You can think of this engine as a SAS workspace server for legacy code. The primary difference between SPREE and the workspace server in our legacy 9.4 environment is that SPREE does not support the SAS metadata server technology, because SAS metadata is part of a monolithic design that precedes the microservices design of a cloud platform such as SAS Viya. In summary, it's worth noting that SAS Viya has two compute engines as denoted by the blue and red boxes. Remember the simple formula, which is SAS Viya equals microservices plus CAS plus SPREE. The Centers for Medicare and Medicaid, CMS, uses SAS Viya to generate insights from large amounts of data, since it leverages SAS high-performance analytic technologies, which includes several runtime environments, as we were describing, and application services. We discussed several in this presentation, including CAS, SPREE, and open source technologies such as Python, but also R. SAS Viya also empowers organizations to explore huge volumes of data quickly with several web browser applications to identify patterns, trends, and opportunities for further analysis. The highly visual drag and drop data interface with SAS Visual Analytics, for example, combined with the speed of SAS Cloud Analytic Services, or CAS, accelerates analytic computations and enables CMS to derive value from massive amounts, big quantities of data quickly. In addition to this, several data connectors or access engines allow SAS Viya to bring in data to its environment from cloud sources such as Snowflake, Redshift, and Databricks, as well as on-premise data sources. And all of this is done in the cloud with a simple, scalable, and secure platform architecture that includes technologies such as containers and Kubernetes. You can almost think of these components as Lego blocks. The benefit to CMS is that it is able to implement solutions that incorporate different components or Lego blocks depending on business needs for statistical analysis, data modeling, data visualization, text analytics, forecasting, and machine learning. These powerful capabilities allow CMS to solve such pressing business challenges, such as fighting Medicare fraud, understanding patient and provider outcomes, and making enormous amounts of text data, such as Medicare regulations, easily digestible. In conclusion, bridging the gap involves a set of best practices covered in our paper to either migrate your current or legacy environment with future state capabilities that we discussed in the previous slides using SAS Viya, or integrate with future state capabilities in the cloud, such as data warehouses, Snowflake or Databricks, and even Python, technologies that enrich and enhance the SAS experience. Our paper discusses these best practices and strategies to help you move from a current state to future state in detail. Any roadmap that's part of a move from a legacy environment to a future state one will benefit from the best practices described in detail in our paper. Thank you very much, and we look forward to hearing from you.